Perimeter and area, and I do. You guys, you have the formulas listed right there, and I think probably you know most of those. Everything. Um, what's nice about the area formula for a triangle is a triangle is just half the area formula for a rectangle. It's like if you were to take a rectangle and cut it in half along the diagonal, you'd have a triangle. So it's half of the rectangle formula. So let's go ahead and try these. First one here, we're going to calculate the perimeter of the rectangle. And the perimeter formula, if you look at your formula sheet there, second one down, it says take twice the length, which is 11, plus twice the width, which is 6, and use that to calculate the perimeter. You could also think of it as just adding up all the sides, right? It's just that there's 2 lengths and 2 widths. So 22 plus 12 is 34 units. Okay, so just plugging it into the formula, or if you want to, you could just add up the sides. 11 plus 11 plus 6 plus 6, and that's your perimeter. And then area is just length, which is 11, times width, which is 6, and so I get 66 square units. And that's it. When you have units attached, it's square units for area. And I'll show you why in this lesson, where those square units come from. All right. For the circle, instead of perimeter, we call it circumference. And circumference is equal to 2 pi times the radius, which is 5. Just be aware that on some of the problems, they give you the diameter rather than the radius. So when they give you the diameter, just cut it in half. Or just take off the 2 and multiply the diameter times half. So either way. Circumference equals, in this case, 10 pi. And if it's just a skill-based, if I'm just asking you to calculate the circumference of a circle and it's not a real-life sort of problem, not an applied problem, just leave it in terms of pi. Okay, so in terms of pi means leave the pi attached. And that's fine to do. When you go to calculate area, you will have to find the radius. You don't use the diameter in the calculation of area. So area is equal to pi times 5 squared, or 25 pi, and you can leave it as 25 pi. So there's some problems that ask you to calculate circumference and area of a circle. That is the only thing you need to worry about is did they give me the radius or the diameter? That's the only thing you need to pay attention to. I think one of them on there, they give you a diameter of 15, so you got to cut that in half and use 7.5 for the radius in the area. But it's really nice. If they give you a diameter of 15, you just attach pi to it and circumference is done. Super easy to do. That's the other formula for circumference, is just pi times diameter. Right, when it comes to triangles, perimeter is just a plus b plus c. And so you're just going to add up 8 plus 10 plus 4. And in this case, that would be 22. Now, what you will find on some of the triangle problems in the homework and assignment is that you have to use the Pythagorean theorem to find one of the side lengths, or more than one. What's that? No, not too bad. But there's actually several of them where you have to find the other missing side lengths using the Pythagorean theorem before you can get the perimeter. I think any of the ones where they have you plot the points and graph it, you're going to end up having to use the Pythagorean theorem to find it out. We'll maybe look at one of those together. I think it's number 15 is one of them, and I have another one, 17, on there that I'm going to have you plot the points, find the perimeter, or maybe or the area of the triangle. Yeah. So
how many questions
on the exam? I'll give you more information on that when we do the review on that. What's that?
D is one of those.
Where, yes, you do have to use the Pythagorean theorem on D. All right, so perimeter is 22. Area of this guy for a triangle, it's just base times height divided by 2. So base would be 10. Height would be that 3 in there. And then divide that by 2. So 10 times 3 is 30, divided by 2 is 15. And then this last shape on here kind of gets at more of the geometry. I mean, this stuff is review, but in geometry, we're going to ask you to find areas of shapes that maybe are a combination of triangles and rectangles. things like that. So that's what this one is. If you draw in this line right here, drawing that line right there, it creates a right triangle. It's a right triangle with one leg of 3 and the other leg of 4, due to the fact that this portion right here has to match the 10 centimeters directly across from it. Okay, so if that's 10, what I just drew in purple, then what's left over of the 14 would have to be 4. And so by the Pythagorean theorem, or distance formula, whatever you want to call it, we've got C equals the square root of 3 squared plus 4 squared. And you'll find that comes out as a whole number. It's actually what we call a Pythagorean triple. It's a 3, 4, 5 right triangle. Anytime you see 2 legs of 3 and 4 in a right triangle, the hypotenuse C will always be 5. So 9 plus 16 is 25. Square root of 25 is 5. And so C equals 5. And now we have the information we need to calculate the perimeter of this trapezoid. We are going to learn the formula for the area of a trapezoid at another time. But right now we're just using triangles and rectangles to figure out the area of this trapezoid. So perimeter equals, it would be 14 plus 3 plus 10 plus 5. So adding up all those sides, 14 and 3, 17 plus 10 is 27, plus 5 is 32. And then the area will be a combination of the area of the rectangle plus the area of that right triangle that we made on the right-hand side of that trapezoid. So the area of the rectangle would be 10 times 3. And the area of the triangle would be base times height. Now in a right triangle, the base and height are the legs of the right triangle. So base and height are 3 and 4 divided by 2. So I've got 30 plus 6, which is 36 square centimeters. And up here we have 32 centimeters. There are actually units on this one. So 32 centimeters for the perimeter and 36 square centimeters for the area. So that's telling you how many little 1 by 1 square centimeters would fit in that shape if it had those dimensions. So then the next few examples are more like what you'll see. They start, I do have some in the beginning of this assignment where it's just calculating perimeter and area of those shapes, just a few of those. And then you'll get into some problems where you're finding some combination of those. Something where the shape might be made up of, like in D, a rectangle and a triangle, or you might take a rectangle and subtract out some circles, like the packing problem in example 3 there in your notes. Trying to figure out what the waste is or the leftover portions, that type of thing. Alright, so here we go. It says the area of a triangle with sides 5, 12, and 13. So I'm not given a picture of it. Not given a picture of it, but based on, based on a little theorem here. Just tap for a hint. Let's see what that hint is. A little theorem from a guy by the name of Pythagoras that keeps showing up here. It's kind of the key to this. In other words, I know this is a right triangle. The reason I know this is a right triangle is because 5 squared plus 12 squared will equal 13 squared. This is another Pythagorean triple that I recognize. If you don't recognize it, you just have to test it here. 5 squared plus 12 squared, if that equals 13 squared, which it does, 25 plus 144 is 169 equals equals 169. So based on that fact, this has to be a right triangle. So if I were to draw this, I would say this is the 5, this is the 12, and this is the 13. And if I know that this is a right triangle, then when I go to calculate the area, I'm just plugging in the legs, the 5 and the 12, for my base and the height. You don't want to use the 13 as your base. It would require you to do a little bit of trig to find the height here, which would come somewhere right through that right angle marking, if you use the 13 as your base. But if it's a right triangle, the legs are the base and the height every time. So my area is equal to 5 times 12 divided by 2, which gives me 60 divided by 2 is 30 square units. So I can calculate the area of the right triangle fairly easily. All right, these circles are supposed to be touching. It's dependent on those touching. We call it tangent. But if you're putting maybe paint cans into a box or whatever, and you're trying to figure out what the waste is. What's that? Or soda cans in a crate box, you know, you can touch. What's the waste is the question. How much cardboard is getting wasted here? So the idea is this: to get the area of the shaded region. So let's switch colors. Area of the shaded. Here's my pictogram of it. Would be equal to the area of that long rectangle minus 3. I should say 3 area. Let's do it like this. Area of the 3 circles is what that is. That's not 30, it's 3 circles. Okay. So it's area of the rectangle minus area of the 3 circles. Put times in there, 3 circles. It doesn't look like 30. So here we go. Area of the rectangle. Well, to figure out the area of the rectangle, I need to know the dimensions of the rectangle. But I told you that these are touching. So the distance from here to here would be 4. The distance from here to here would also be 4. Distance all the way across there is 8, and across there is 8, placing those 2 radii together. So we've got 3/8, which makes 24, and then we've got 1 diameter going vertically, which gives us a dimension of 8. So that gives me the dimensions of the rectangle. So I've got a base or length of 24 and a width or height of 8. And then I have minus and the area of the 3 circles. So we've got 3 times the area of one of the circles, which would be pi times 4 squared. Pi times 4 squared, or 16 pi. So I end up with the following expression: 24 times 8, 192, minus, and I'm going to leave this in terms of pi, 16 pi times 3 is 48 pi, and then I'm going to use my calculator to figure this out. So we've got our expression, what we'd say in terms of pi. We're going to wait till the very end to round so that we can be as accurate as possible. So using my calculator, I'm going to plug it in just as I wrote it there, 192 minus 48, and then use the pi button instead of 3.14. So here we go. It's 198 minus 48, and then you should have a pi button on your calculator.
It's 192.
Was it 192? Okay, let's change that to 192. So 192 minus 48 pi. Just plug it in like that on your calculator, and then round off at this point instead of using 3.14, multiplying it by 48, rounding off, and then subtracting that and rounding off again. So 41.2 is the wasted area for that guy. So 41.2. units on there. So square units, whatever those are. So you should be able to put some combination of those shapes together and figure out the missing area, that type of thing. All right. This last couple, each involve. Let's see here. At least number 4 involves Pythagorean theorem. So here's Tom. He's going to hike south 7 kilometers. So Tom starts right here. He goes south 7 kilometers. Put a 7 on there. And then he turns west and hikes 4 kilometers west. So I'll make that 4. I tried to make that shorter than the 7. And then he's going to hike north 3 kilometers. So we'll try to make that a little shorter than this 4 here, maybe 3. And then he stops. How far is he from his starting location, straight line distance here? So in other words, we need to find that distance right there. So what you can do is go ahead and draw in a base there to that right triangle. And if I do that, I know that if that's 4, so is that. I've got a right angle right here, so this is a distance problem or Pythagorean theorem problem. Distance is going to be equal to the square root of 4 squared plus, okay, what is this length right here going to be? That's going to be 4 as well, because you got to take the 3 from the 7. So I've got 4 squared plus 4 squared. 16 plus 16 is 32. It would probably make sense on this real life sort of problem to get a decimal approximation. So square root of 32 is about 5.6, 5.6 kilometers. And so we're looking for right triangles in these problems. There's a lot of these where we're looking for right triangles. Right here, area of a triangle, we're going to plot 1, 4. You don't have one on yours? Okay, so make one. So make a graph. It looks like this. This is a first quadrant graph, so maybe make a graph. You can actually do this without a graph. I'll show you how. But it would be helpful to have a graphing grid there. So we're going to make a graph. Let you do that first. And you could probably just go out. You have to go out at least 7 on the x-axis. It looks like 4 on the y would be sufficient. Try to evenly space your little marks that mark 1, 2, 3, 4. And then we're going to plot a point at 1, 4, a point at 1, 1. So here's A, B, and then C at 7, 1. And so when you plot the points, you're looking for right triangles here. It's like we end up with one right off the bat. And then you're just going to count on the grid to figure out the base and the height. So from B to C, I've got 1, 2, 3, 4, 5, 6. You can see that from B to C. Look at the x coordinates of B and C. What's the difference between the x coordinates of B and C? 6. So you can see it. You can do it without a grid. And then from A to B, what about from A to B? What's the difference in the y coordinates from A to B? 3, yeah. And you can count it on the grid too. I have some graph paper I can loan you as well if you need it. So when I go to set this up, the area is going to be equal to base, which is 6, times height, 3 divided by 2. And so we've got 18 divided by 2, or 9 square units. I want to show you what that looks like on here. 9 square units. I mean, you can start to see it here. Here's 1, 2, 3, 4, 5, 6. Those may not be whole ones. And then somehow the rest of this, here, 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 and here, end up being 3 more. So you put those, maybe a couple of dots together, you get another one, another square. So when we say area being in square units, that's literally what we mean. It's how many little squares of a particular length fit inside of that shape. That's what area means. All right, now on, I think it's on number 15 on your assignment. I'm hoping you can get to that today because I want to talk briefly about that. It's a variation of this. It's a little more difficult because it doesn't pop out as a right triangle right away. You're going to be asked to find the perimeter. So you're going to have to use a Pythagorean theorem, actually, I think twice, to figure out the 2 missing side lines. So we can look at that together once we get there. But I'm going to have you get started on the assignment.